Okay, so let me share the screen, the correct screen. Can you guys see the homework?
Yes.
All right, so and back in the beginning of the semester, right, we did limits and we said based on the power, uh, the degree of the denominator or numerator that would determine your your what's it called? Your limit. Now, in this section, whenever you have an indeterminate form, meaning 0 over 0 or infinity over infinity, you can use this rule called L'Hopital. This is some French guy's last name, I think. Um, and if you use that, then you take a derivative of the top, derivative of the bottom, and then you try again. Take the limit. So you try the first time. If you get 0 over 0 or infinite over infinity, take a derivative again of the top and bottom separately. You don't do a quotient rule, you do completely separate derivative. And then you plug it in again. That's all you do until you're allowed to plug it in. So instead of doing all those other rules, you can use this. Let me write this question down. I believe this is six, no, what the hell is it called? 5.6. I believe it's called L'Hopital's rule. Yeah. Okay. Number one. Use L'Hopital to find the limit. For this guy, the limit as x approaches 10 of x squared minus 8x minus 20 over x minus 10. Okay. So first thing you should do is try to plug in the limit, then see if you get 0 over 0 or infinity over infinity. You can only do L'Hopital if you have that indeterminate form. Let me make a note here. Yeah, 0 over 0 or infinity over infinity. This is called an indeterminate form. I can't fit it in there, but okay. So first, let's see if I take the limit. Actually, let's factor. That might be easier to see it instead of doing all this number crunching. Factoring the top would be, let's see. Mm, okay. So you can see right away, right? If I plug in 10, I'm gonna get 0 over 0. Take the limit. Can't do it. So this tells us try L'Hopital. So the limit of this guy well, I'm going to make a little symbol here, call it LH. I'm going to use L'Hopital because I have an indeterminate form. It wouldn't matter, right? It'd be 0 times this. So it'd still be 0. So since we have nothing but 0 and over 0, then you can use this. So don't actually take the limit, just take the derivative of the top. What is the derivative of just the numerator? Yeah, it looks like 2x minus 8. On the bottom one will be just a 1, right?
2x minus 8, right?
Yeah, 2x minus 8, correct.
Oh, okay.
So now I no longer have 0 over 0 if I plug in the limit, right? We'll just take the limit to get 2 times 10 minus 8. So 20 minus 8, 12. That makes sense. The main idea. Sorry, I kind of spaced there. Okay. So I took the limit using L'Hopital's. We're done. Not too bad, right? Okay. Number 2, same question. Okay, yeah, this is a good one. Number 2. Okay, take the limit. You see the issue, right? Keep going if you don't. You see that this is 0 over 0. So now that we know it's indeterminate, do L'Hopital. Make a little symbol here so you know that I'm doing it. So the derivative of the bottom is a 1. What's the derivative of this square root part? What's going to happen there?
Would it be square root of 2x?
No, because we have to do the chain rule part.
Okay.
You see how the function of the outer function is a square root. The inner function is a 1 minus x squared. So you'd have to first do here. Let me show an extra step. in case you're not a pro with the chain rule just yet. Oh, you forgot. Excuse me. Okay. To bring down the 1/2. So now we do L'Hopital right here. So you bring down the 1/2, right?
Yes.
Subtract 1, so that'd be -1/2, and then times the derivative of the inside. Derivative of the inside is
2x.
negative.
Negative. Yes.
Okay, so now we did derivative of the bottom, derivative of the top. Now, can we plug the limit? Looks like we should be good, right?
Can we cancel the 1/2 with the negative 1/2?
With the 2, yeah, with this 2. That's a good point.
Yeah.
Okay, cancel this with this 2. So I'll make one more little step here. It's going to be negative because there's a -2 right there. Okay. Over 1. So plug in your limit. This would be -1 minus 0 times 0 over 1. So this limit would be 0.
Yes.
Any questions on the Okay, so move on to the next one then. Okay, so it's going to be the same thing over and over again. Just verify, okay, do I have 0 over 0? Do I have infinity over infinity?
How do you verify if it's 0 or 0 or infinity or infinity?
So I guess the first thing you should do when you start these questions, let me show you. Is plug in the limit and see what happens, right? So if I plug in, let's say right here, if I plug in a 1, I'm gonna get -1 on top, and on the bottom I get 1 minus 1, so that'd be 0 over 0.
Okay. So what you get as a final answer, you should plug that into the original function and see if it's the 0 or 0 or infinity, right?
Yeah, just take the limit and then see, okay, do I have indeterminate form?
Okay.
And then if you do L'Hopital's rule.
Okay. Got it.
So here's another one, right? If I plug in 0, you'd have sine 0 over sine 0, which would be 0 over 0. So do L'Hopital.
Yes. Okay.
Okay, so let's do 5 and 6, and then maybe we'll move on to something else.
Did we had class on Tuesday? Because I wanted to join, but I wasn't able to.
No, I gave you guys Halloween off, remember? Told you on Thursday. Or were you here Thursday?
I was here Thursday, but not Tuesday.
Oh, okay. Maybe you didn't hear me that day.
So it was a day off, right?
Yes, no one was absent that day.
Oh,
Okay, let me see. Number 5. Yes. Find the limit. Yeah, I was hoping to go do some Halloween stuff, but ended up grading all day long. Still not done. Okay, find the limit. Using abbreviated. Take the limit, you would end up with sine 0 over 0, or sine 0, which is 0 over 0. Okay, let me switch back. No, I'm sorry, Annalise. I hope you didn't cancel plans or something. So L'Hopital, take the derivative of sine 6x and sine 5x. Derivative of sine is going to be gotcha. Maybe next time. One of my best friends was a hermit. He's a super cool dude, though. Derivative sine is cosine times 6. Yeah, so chain rule, derivative of the inside is 6. Same thing down here. Derivative of sine 5x is going to be cosine of 5x times the derivative of the inside 5. Now take your limit, and you'll have 6 cosine of 0 over 5 cosine of 0. This time this will be, I'm running out of space, 6 times 1 over 5 times 1. Any questions on number 5?
no questions.
Okay. Okay. Yeah, number 6. This one has actual infinite limit. Um, but right away you should see, well, maybe you remember from chapter 2, we said if you have an infinite limit, if the degrees are the same, right, we would just, we would take just the coefficients. But this time we're going to use an actual official rule. If you plug in infinity, you would technically have infinity over infinity. So do L'Hopital right away. That'll be the limit as x approaches infinity of 6x plus 9 to your derivative over 4x. Yeah, just 4x. If you take the limit again, do you see that it is infinite?
I didn't get it.
I'm sorry. What don't you? What's wrong with it?
No, nothing is wrong with it. I just wanted to know how it's equal to infinity over infinity.
Oh, sure. So if you plug in if you let x go to infinity, right? So the limit is going to infinity. So the numerator will be infinite, the denominator will be infinite.
Yes.
Over here, if you let x go infinity and x go to infinity, it'll still be infinite over infinity. No matter what.
Okay.
Do you see?
Okay. Yes, I got it.
So it doesn't change. So you have to do it again. So derivative of the top will be 6 over 4, right? So the limit would
Yes.
simply be this.
Okay.
Okay. Yeah, you would enter the limit as 6/4, right? Yeah, the actual limit would be right here. So just 6/4. That's it. Just make sure on the exam, make sure you do your steps, but the homework just wants this. Alrighty, let's see. Well, you would take a derivative of the constant, it'll be 0. Just like this one, derivative of -5 is 0. Derivative of 9x is 9. Derivative of 3x squared is 6x. So do another one. This is going to be gone, and the 6x becomes 6. So at this point, you let x go into infinity, but there is no x, so it's just going to be 6/4 no matter what. Okay, so that's pretty much it for this section. Let's move on to something else. You guys have any questions on 5.6 before we move on? Sure. Yeah, that's fine. 7. Okay. Oh, 1 second. Just checking the date here. Okay. Number 7. Okay. That looks ugly. Let me write that again. So that's 5 times e to the x over 3. Okay, so if I let x go to infinity, you're going to have infinity on top. And e to the infinity would also be infinite. So for sure, do L'Hopital. Derivative of the top would be 3x squared, right? Derivative of the bottom would be the same thing times that chain rule. So it'll be 5 e to the x over 3 times 1/3. We write that prettier.
How did we go from x cubed to 3x squared? Because I know if you go around 3, it would be 3x, but I don't know how to get to 2.
Oh, so the power rule, remember you bring down the 3, right?
Mm-hmm.
Subtract 1 from the power.
Oh my God, I always forget that. I'm sorry.
Oh, that's okay. This is the time to ask questions.
This is my 3rd time I think I'm asking this question again and again.
Yeah, make sure you practice. I don't want you to get stuck.
Okay.
Okay, so we get 5/3 e to the x over 3. So still infinite. We do it again. So Tom basically looks like this is going to keep going forever for the e. The top is going to be, eventually will zero out. So let's show our work. It's going to be 6x for another derivative, right? Bring down the 2. 2 times 3 is 6, subtract 1. This will be the same thing times another third. That'll be 5 over 9 e to the x to the 1/3, or e to the x over 3. All right, one more time. Looks like all we need is one more. L'Hopital. So this will be 6. Bottom will be the same thing, so times a third, and that'll be 5 over 27 e to the x over 3. It's getting a little messy there. So now there's no more x's on top, right? So if you take the
Yes, no
limit,
more.
what's going to happen?
Would it be infinity?
Well, the bottom is getting infinitely big.
Okay. Or it stays the same.
Well, if it gets infinitely big on the bottom, that means the entire fraction would get infinitely small. So this would become 0. Does that make sense?
I don't know if I understand this.
Well, let's think about it. Let
I'm
me show
in the
you
lab.
on the calculator. You agree that 1 over 10 is 0.1, right? If I make the
Yes.
bottom even bigger, right, what's happening?
It would be smaller, right?
Yeah. So if I make it go to infinity, then it's ridiculously small that eventually it goes to 0. So
Yes.
if the denominator is growing without bound, this is going to 0 here.
Yes, I got it. Now I got it.
Well, we don't no longer have an indeterminate form, so we shouldn't use L'Hopital here. But yeah, it is tempting to do derivative there. Um, I think I have the 1 second. Let's double check the rule. Mhm. Yeah, it has to be 0 over 0 or infinity over infinity. So we'd have to just take the limit here. We cannot do a derivative again. Okay. Let's see if we have time for optimization. Let me open it up.
Hey, Professor, so on
Mhm.
that last part,
Yes.
you put equal to 0 because there was just no there wasn't a next derivative to go by, right?
One more time. I'm sorry. with this guy,
So
right?
that last part, because it's equal to 0. I mean, you put equal to 0 because like we can't find another derivative, right?
No, the limit is 0 because this fraction will go to 0 if x grows without bound. So if I let this x in the exponential, right? Because this is e to the x over 3, and 3 doesn't really matter. But you have an exponential function that grows really fast, and then you let that x go to infinity, then the
Oh.
entire bottom is getting infinitely big. So the fraction just zeroes out.
I gotcha.
All right, let me pull up. Let's try to do one more section. That way we can stay ahead. Things are going pretty good so far. And then we'll see if you guys have questions. Where is that section? The next section is a little more difficult, so I'm going to pull out some notes here. It's a very useful section, though. This is section 4.7. Okay. Here we go. Sorry. I'll be sure to post all the videos from today and last time. I don't think I had a chance to download them yet. Okay, so optimization is basically an application of minimum and maximums. So you just apply it to something useful, like let's say, I don't know, let's say you wanted to build a fence and you wanted to maximize the area given a set parameters. Let's say, so you know what, the fence requires me to build it by this perimeter, or I have to have this length, or maybe you only have so much backyard and you want to section off a certain part, but you want to have maximum area given a fixed side or whatever, right? So that's what this is about. You maximize something. It could also be profits, could be pretty much anything because functions represent whatever the hell you want. So optimizing means maximize or minimize whatever you want. Minimize cost, maximize profits. I don't know. So let's start off simple. I think this is one of the first ones in the homework. Find the length and width of a rectangle that has the given perimeter. And a max area. Okay. So in this question, they're going to give us perimeter. So they're basically telling us, okay, you can make it this much distance around 72 meters. So you choose how you want the length and the width. That way, choose it in such a way that the area is maximized. Okay. So in order to do so, we're going to need the perimeter formula for a rectangle. We're going to need the area formula for a rectangle. Okay. So what I recommend is try to put this into in terms of one variable. That way it doesn't get all strange and you can solve for one variable. So take the perimeter formula, set it equal to the perimeter that you have, solve for, let's say, L, I guess. I'm going to solve for L. So subtract 2
Plus
W.
2W, right?
Yeah, I'm going to move this guy over to there. So this will be L. 72 divided by 2 is 36, right? Minus
Yes.
W. Okay. So there's my length. We're going to plug this into the area. Okay. That makes sense. So that way we have, if we plug in L, we'll have a quadratic in terms of just W. And then we can maximize area in terms of width. Okay, so here we go. So A is equal to L times W, which means that A is equal to, I'm not gonna write the 36 meters anymore. I'm just gonna leave it as 36 for now. Just remember this is all in meters. Okay, you guys still with me up to this point?
Yes.
Okay. So that would be 36W minus W squared. So there's my quadratic. This is the one you want to maximize because this is your area function. And we made it depend on width. So once we find the maximum area given that width, then we can plug that in to find your length, right? Plug it in here. Okay. So take the derivative with respect to width. So the derivative of A over with respect to W would be 36 would be gone. This would be equal to negative. No, actually, sorry, it's not gone.
Isn't it 36?
Yeah. There we go. All right.
Yes.
So going back to chapter 4 And beginning of chapter 4 and chapter 3, how do we find maximums and minimums given any function? Why did I take a derivative?
Do we not first find the value of W to find the MO area?
I'm sorry, one more time.
I mean, is it possible to first find the W so to make it easy to find the length and area?
Well, that's what we're trying to do. We're gonna find the W that gives the maximum area. But the reason we took the derivative was because, remember last few sections we said if we set the derivative equal to 0, we find critical numbers, right?
Mm-hmm.
Those critical numbers correspond to maximums and minimums.
Yes.
So this is some parabola. So the peak of the parabola will be the maximum width.
Okay.
So set the derivative equal to 0, right?
Mm-hmm.
And solve.
We will move 36, right?
Yeah, so you're going to get width of 18 when you solve it.
Mm-hmm.
So let me make a note here. The area formula into one variable. And so we did first. Find the critical number of the area function. No. We should use a first derivative test to test around this number, but this is a parabola. There's only one critical. This is going to be the peak. Okay.
The maximum?
Yeah, it's going to be a maximum. All right, so let me skip that part. Well, maybe we do it back here. You guys cool so far?
Yes.
Okay, so let me know. So I'll go ahead and do the first derivative test just because we're still learning it. All right. So test around 18. I'm going to choose 0 and I don't know, 19, I guess. The derivative function was of this, right?
Yes.
If I plug in 0, positive.
It would be 36.
Mm-hmm. What's 2 times 19?
38.
38?
38.
Yes. Can you hear me? Sorry.
Yeah, I got you.
Okay, sorry.
Thanks. Okay, so minus, right?
Yes.
So as we already knew, maximum. So maximum area when width is equal to 18 meters. If width is 18, what does the length have to be?
$18?
We said length is equal to 36 minus W, right?
Wasn't it 36 minus 2W?
For the length equation,
Oh, I got it. Yes.
yeah.
It was L times W, I guess.
Yeah. So in this one, it just so happens to be the same. That's kind of lame, but
Mhm.
that rarely happens. So it turns out a perfect square for this specific question is the maximum area. But usually that's not the case.
Mhm.
But does the procedure make sense? Do you see how we're given a restriction? Let's just go start from the top. They said you have to have this perimeter, and I want maximum area. So like just assume some guy gave you some contractor or whatever. He's all right. I need you to do this. So how do I find the maximum? Well, maximize the area formula for a rectangle, and that's what we're doing. But in order to make it easier, we change area into one dimension because we're doing mainly one-dimensional problems in calculus 1.
Yes.
So now that we have it, we can maximize or find the maximum of any function, because that's what we've been doing,
Mhm.
by taking the derivative and setting it to 0, giving us a critical number. Now we test to see if it's minimum or maximum. We should know that it's going to be a max. But if not, we test it and find out. And once you test it, just plug it into the length formula, then you'll get your length. Any questions on these ideas? This applies to any type of problem or formula you want to maximize. Okay, so you guys are good on this first one?
Yes.
Okay. Yeah, this theory applies to any dimension, although it gets more and more complex. If you're trying to maximize like a high-level function or a volume, but in essence, it's still the same. You're using the derivatives. It's just that the derivatives might be a matrix instead of a simple line like this. It just depends. Let's see. Number 2 is minimizing perimeter. Okay. This one's similar. Let's do this anyway, even though it's similar, just so we get more practice. So this time they're saying you have this restriction of an area of 16 square feet, but they want you to minimize perimeter. That way you don't use too much material. So give me that specific area without with the minimal amount of material. It's basically what it's really asking. But in math terms, you're saying find the length and width in feet of a rectangle that has the given area and a minimum perimeter. So that's the key word. I'm minimizing perimeter. So I'm going to take derivatives of the perimeter formula eventually. The area they're giving us is 16 feet squared. So again, we got our formulas. If you don't remember the formulas, put them on your formula sheet or create one. I don't expect you to memorize every geometrical formula. It's not a big deal. Okay. But use the same technique. They said, try to get this. So we're going to minimize perimeter. So get perimeter into one dimension. We have area, right? So use this guy. I'm going to solve for L again, just because. Divide both sides by W. And then just plug it in. Then you won't have any more L's. So P would equal 2 times 16W plus 2W. Using this. That makes sense?
Yes.
All right. Okay. So multiply your 2, that'll be 32W. I'm going to bring that W to the top and make it a negative power just so it's easier to deal with. Is that all right?
Mm-hmm.
So now take your derivative and find out where you have your critical values. So dP, dW, derivative of this guy would be negative 32W minus 2 plus 2. Okay. Now, same thing. Set this guy to 0 and find the critical numbers. Okay. So 0 equal to negative 32W plus 2. Solve for W. I guess I'll move that 2 over. I'm going to change it back to a positive exponent. You can do cross multiplication or just basic, however you want to think about it. Just get the W on top. You can also just flip both sides over to get this. Multiply this by negative 32. That'll give us W squared equal to positive 16. Square root both sides would give us plus or minus 4. All right. Finally, that one was a little weird, but it's just the algebra, right? We have w equal to 4 and negative 4. Okay. Can I use negative 4? Does that even make sense? Is there such a thing as negative width?
No.
Yeah, so we can rule that out real quick. So the width should be 4. Okay. So just plug it in. So if width is 4, then I should be able to figure out like the width is equal to 4 feet. Length would equal 16 over W, which is going to be 16 over 4. Oh man, I picked another easy question. My bad. I don't know why I did that. Pick something harder next. It's not supposed to be square all the time. I pick stupid problems. Sorry about that. Let's pick something completely different now. But before we move on, do you have any questions on the big picture idea? All right, can you minimize a random formula? Can you do some algebra to make that formula easier to work with? Can you do the first derivative test to figure out if it's a minimum or maximum, etc.? Any of those ideas not make sense?
From at the end where we get w squared over negative 32, how does that equal to negative 1/2?
Here?
Yes.
Okay. Which step? From this line to the next one?
No, from this w squared to negative 1/2.
Oh, from this to here?
Yes. No, I'm
Okay.
sorry. W squared over negative 32 from negative 1/2 to negative 1/2.
Yeah, okay. So the step right after this, I multiplied both sides by negative 32. So 1/2 times negative 32 is positive 16. That
Okay.
would cancel the fraction. So I skipped the algebra here. So the algebra that I did though is subtract 2
Mm-hmm.
and then bring this w back to the bottom.
Okay.
I took the reciprocal of both sides, so I flipped this one over and I flipped the negative 2 over.
Okay.
By both sides by negative 32 gets me to there. Square root both sides gets me to plus or minus 4. There's many
Okay.
ways to do this. I was just doing the shortest thing I could think of. You could do like a cross multiplication or however you want to think about it. It doesn't matter. Just make
Oh.
sure we're just solving for W. That's all.
Oh. Good.
Okay. So this time, let's do something more complex. We will have a cardboard box. And we're going to fold up let me see here. We're going to cut up the corners, fold it up into a box. So we have a flat piece of cardboard, cut the corners, fold it up, create a box. Determine the height of the box that will give maximum volume. That's what we're going to do. So we have a piece of cardboard that is 14 inches by 10 inches. And we will cut out the corners and fold it up into a box. Determine the height of the box that will give a maximum volume. So basically, we're trying to figure out how much do I fold it upward, right? If I fold too much or too little, I'll have more or less volume. It just depends. So what is the perfect shape? Okay, given that we're doing this. Does that make sense? Let's draw a picture. Okay, we got some cardboard. Oh, 1 second. Okay, sorry. All right, 14 inches is right there by 10 inches. So I'm going to try to picture this. I'm going to cut out these corners. They're going to be uniform cuts. Okay. I know they don't look perfect, but my handwriting and drawing skills are not very good. So all these are H. 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 Okay, so I'm going to fold it up here and there. So imagine it was perfectly cut, whatever. We're trying to figure out how much to cut in order to fold upward. So we are maximizing volume of a rectangular prism. And we are using we need to have it in terms of height, because the height is going to determine the volume. Do you see that?
Yes.
Okay, so let's write down the formulas first, because I know this stuff can be hard the first time. And to be honest, I failed this test when I first took calculus, so don't feel bad if it looks hard. It took me a bit. Okay. Do you see why I chose this to be my length and width? Does it make sense? We have a length of 14 inches, but I'm going to subtract an h. I'm cutting out h and h, so it should be minus 2h. I have a width of 10, so subtract 2h. So this section right here is 14 minus 2h. This right there is 10 minus 2h. That make more sense?
Yes.
Okay. Alrighty, so we want everything in terms of h. And we kind of already have it, don't we?
Yes, but do we have the value of h?
No, everything will be in terms of h. And then we will maximize volume by depending on h. Because h is going to determine the depth.
Yes.
So V,
So, are we searching for H? I'm sorry, I didn't mean to interrupt.
yeah, we're gonna maximize volume in terms of h. So we're gonna take the derivative of V with respect to h.
Oh, okay.
And that will give us the specific h we need for maximum volume. And that'll tell us how much to cut. Okay. So V would be equal to L times W times height. Boil all this garbage out. I'm going to skip that step. Multiply all of this. You should get this. That okay? I believe you guys can multiply this out, right?
Yes, of course.
To save some time. If you
Mhm.
want to see it, let me know. I'm not gonna judge you or not do it. Just saying.
So you just multiply 14 by both sides and then negative 2h, right?
Yeah, I do 14 times 10, 14 times 2h, negative 2h times 10, negative 2h times negative 2h. That result will then be multiplied by h.
Okay.
That would be this.
Mhm.
So it should be a cubic. What's the derivative with respect to h?
We are finding the first derivative, right?
Yeah, just the first one.
Oh, so it would be 12h
Mm-hmm.
minus 2. 88, I guess. Do you get that? 2
No.
times 4.
96.
96. Okay.
140. Right?
Mhm.
Okay. So we got the derivative. So the rule says we will have 12h squared minus 96h plus 140. So factor this guy. Or quadratic formula or whatever. I don't care how you do it. Many ways to solve quadratics, right? Okay, so far you guys okay? I'm gonna turn to the next page. Any questions about the setup? I think that's in my opinion, that's the hardest part, is trying to visualize what's going on. Okay. So I'm gonna use quadratic formula just cause.
I can't see it, Professor.
Sorry about that.
No problem. You're gonna use the quadratic formula, right?
Mm-hmm. So here's a quadratic. Okay, plug in everything. B is negative 96. B is 96, yeah. For AC over 2A. Okay. Double negative would make this 96. 96 squared is 9216. Negative 4 times 12 times 140. 2 times 12. Okay. I'm going to skip through this because it's a quadratic formula. If you have a question on it, let me know. Eventually you will get. Eventually. You'll get. I use X. That's not true. We're finding H, right? Okay. Eventually you get H equal to 6.08 and H equal to 1.92. So we need to test both of them and figure out which one is the maximum and or minimum. Okay. And we want to have maximum, what did we say? We want the height that gives you maximum volume. Okay. So what we could do is take another derivative and use the second derivative test. These are easy to take derivatives, power functions. So the second derivative would be simple. And if we plug in these numbers into that second derivative, we will know if it's maximum or minimum. Because we said if it's positive, then it is concave up, which is a minimum. If it is negative, it's concave down, which is a
Maximum.
maximum. So there's a second derivative. So I'm going to make a note here. Test both H values in the second derivative to determine max min. So that is the second derivative test that I'm using here. You could have done the first derivative test if you wanted to, but it is easier to do this because this is a simple function to do a second derivative of.
Yes.
Got like 2 here. So at 6.08, you would get 24 times 6.08 minus 96. Running out of space. If I plug in 1.92, it'd be 24 times 1.92 minus 96. What do we get here? I got 49.92, negative 49.92. So this means concave up, concave down. So maximum when our height is 1.92. So we need to cut the box corners around 1.92 inches. That'll create the most depth, the most volume.
The question asks for the maximum, right?
Yeah, so they want the height. What height gives the maximum, and then give them the maximum. So let's go ahead and do that next. But so far, is logic making sense?
Mhm.
Okay, so we're going to plug in this guy, because this turns out to be the maximum, into the
Mhm.
original volume.
Okay.
Because we want to know the volume, plug it into the volume. So okay. So our volume formula was something weirdo, remember. Here it is. 4h cubed minus 48h squared plus 140h. V at 1.92 crunch those numbers, you should get 120.164 inches cubed. So the maximum volume of the box would be this if I cut the corners to be 1.92 and then fold the box up that amount.
So this is the final answer, right?
This is what they asked for, and this is what they asked for.
Okay.
What is the optimal height to create the maximum volume?
Okay.
Any questions on any of those steps?